There is a headline circulating in the tech world that sounds almost too good to be true. It claims that Google says 75% of the company's new code is AI generated. If that number were accurate, it would represent a fundamental shift in how humanity builds software. It would mean that the vast majority of the digital infrastructure we rely on is being constructed by machines rather than human hands. But before we accept that figure as absolute fact, we need to look closer at what is actually happening behind the scenes. Research into the available data suggests a more nuanced reality. While Google leadership has confirmed that they are using AI tools extensively, the specific figure of 75% appears to be a conflation of different industry estimates. Some reports suggest that more than a quarter of new code is reviewed or generated with AI assistance, while other industry surveys indicate that a similar percentage of developers plan to use these tools. The exact number matters less than the trajectory. Whether it is 25% or 50%, the trend is undeniable. We are moving rapidly toward a state where AI generation is the default baseline for software development. Now consider the implications of this shift for the people actually working on the code. For decades, the role of a software engineer was defined by the act of writing. You would sit at a terminal, type out logic, and build systems from the ground up. Today, that role is evolving into one of orchestration. Developers are becoming reviewers and validators. They are no longer just architects building the walls, but they are also the inspectors checking the quality of the bricks being laid by an automated system. This sounds efficient, but it introduces a hidden cost that is rarely discussed in productivity reports. This hidden cost is what we might call the maintenance tax. Every line of code that exists in a system requires maintenance. It needs to be understood by future engineers. It needs to be patched when security vulnerabilities are discovered. It needs to be updated when the underlying libraries change. When humans write code, they usually understand the intent behind the logic because they made the choices. When AI generates code, the intent is often opaque. It is a probabilistic output based on patterns in training data rather than a deliberate design decision. Imagine a construction site where a robot arm is laying bricks at a speed that would make a human crew look like a snail. The building goes up incredibly fast, but if the robot does not understand the structural load requirements, or if it uses a brick type that degrades faster in the rain, the building will eventually crack. In software, this manifests as technical debt. You are trading speed for stability. You are getting a feature deployed today, but you are inheriting a bug or a security risk that will cost you 10 times more to fix next year. The velocity of production increases, but the velocity of understanding decreases. There is another layer to this problem involving security and stability. As AI tools become ubiquitous, they begin to rely on the code they have seen before. If the training data contains deprecated API patterns or insecure coding practices, the AI will replicate them. This creates a scenario where the ecosystem becomes polluted with bad patterns that look correct but fail under pressure. We are already seeing reports of a strategic crisis where deprecated API patterns are breaking the ecosystem. This is not just about small bugs. It is about large-scale internal migrations failing because the AI-generated code relied on functions that no longer exist in the current environment. This creates a feedback loop that is difficult to break. The faster you generate code, the more you accumulate this debt. Eventually, you reach a point where your engineers are spending all their time fixing the output of the AI rather than building new features. The productivity gains from the initial burst of generation are eaten away by the cost of maintaining the slop. It is a classic economic trap. You get a short-term boost in velocity, but the long-term cost of sustainability skyrockets. To make matters worse, there is a significant learning curve for the developers themselves. They are not just learning a new tool, they are learning a new way of thinking. They have to become proficient in reviewing machine logic, which requires a different set of skills than writing it. This requires a mindset where skepticism is a virtue. You cannot blindly trust the output, you have to verify it. This slows down the process, but it is necessary to prevent the collapse of the codebase. So what does this mean for the future of software engineering? It means we need new quality assurance frameworks. We cannot treat AI-generated code the same as human-written code. It requires a different kind of scrutiny. We need tools that can trace the provenance of a line of code and understand why it was generated. We need systems that can detect when an AI is suggesting a pattern that is becoming obsolete. The shift is not just technical, it is cultural. Developers are increasingly responsible for validating AI output rather than writing code from scratch. This changes the core role of software engineering. It requires a mindset where skepticism is a virtue. You cannot blindly trust the output. You have to verify it. This slows down the process, but it is necessary to prevent the collapse of the codebase. Thanks for watching all the way to the end. I am a one-person team working hard to make each video better than the last. Subscribe if you found value. It is the best way to show support. Drop a comment with your biggest takeaway. See you in the next video.